So, like Sanket so kindly introduced me, I have been working on real-world data science problems for about a decade now. And like most of you, I transitioned from a different domain, that being robotics and core engineering. So, the journey that most of you are about to embark on, I have kind of went through the same thing. And trust me, it's very doable and it's a very lucrative and rewarding thing. So, you guys are here because you're interested in data science and you want to learn how to be a data scientist. But have you wondered, like, why is everyone so fascinated with data science? What is it about data science? What is it about AI that seems to captivate people that you guys are here to learn about? So to answer that question, we kind of need to ask another question to illustrate the point. Do you know how much data is created in a single day? In a single day, from every user around the world, how much data do you think is created in total? And billions of terabytes, trillions, quadrillions. So, like my physics teacher used to say back in high school, include the unit as well. So, petabytes of data, which trillions of petabytes of data, that would be kind of an accurate number. So, if you guys are, a lot of you are kind of right on the mark. So, that's kind of a very big number, is it not? Like, it's so big that most of you will never see something that big. Like, it's that big. And it's so big that we cannot even imagine it. So the actual number, and again, this number might be a bit out of date, but when this kind of these statistics were gathered, so 2.5 quintillion. So it's such a big number that, well, it's not even ingrained in most of our minds. We know millions, we know billions, we might even know trillions, but that is how much gigabytes of data is kind of generated on a daily basis, from all of our smartphones to our smartwatches to IoT devices to our laptops to even home cameras. Like, each one of these devices kind of generates a plethora of data. And so much so that, yes, it's kind of an avalanche of data every day. And the thing is, people, companies, they need to make sense of this data. Now, even Zoom is probably, while we conduct this session, they are collecting statistics about, again, the session. They're collecting statistics about how the video is performing, how the connection is for everyone, and stuff like that. And of course, their engineers are going to use this data to improve their own services. They probably have a team of their own data scientists who work on this problem kind of on a daily basis. And that's kind of where the crux lies in. Just to kind of drive the point further home, again, this data is also kind of outdated, but it still illustrates the point quite well. Um, in around, I believe, a second, you have around 66 new accounts created on Twitter, maybe by bots. You have around 34,200 tweets. So in a second, like, this, how many tweets are published by different people all over the world. If you look at YouTube, in a second, so many people around the world are going to be watching YouTube that it accounts to, or it adds up to, basically 13,884 hours of video playback. Just in 1 second, that's how many people are watching. And around 12 hours of video are uploaded. That's how many people are uploading. Like, you can do the math, that's a huge number. And it applies overall to all of these services, to LinkedIn, to Skype, to Zoom. Well, Skype is, again, not as frequently used, but that's still a big number. So you can imagine how much services like Zoom or Google Meet might be consuming in terms of data. And just like when you have a house, you'll typically have a cleaner whose job is to take care of the house. We tell you, okay, this is not working, this needs to be fixed, this, maybe the water is leaking, so you need to fix this. And then you take care of it. Similar to that, like, you have a lot of mess. The data is messy, it's a lot, it's a lot. And you need to kind of separate what you need from the trash. And that's basically the job of data scientists. So moving on to the next slide. So we kind of looked at how much data is generated, but do you have a deep understanding of what data actually is? Because this helps you quite a lot in understanding deeply the data science process. So data in itself is just a collection of some facts. And these facts can be numbers, they can be words, they can be measurements, observations, or even description of things. So this video that you're seeing right now, the screen that I'm sharing is basically kind of a fact. It's what's being displayed on my computer being shown to you. Similarly, what you're seeing in the chat box of Zoom is also data, but data can also be in multiple different forms. So typically as data scientists, we divide the data into two parts, which makes it easier to process them because, well, as we'll see, one is qualitative data and the second is quantitative data. And in terms of qualitative data, what happens is it tells you about a quality, or it's kind of like a description. So anything that's not really a number is basically qualitative data. For example, the sentence, "It was fun," or me speaking right now. Then you have quantitative data, and that's data that is in the form of numbers. That is something that you can count. And it is also further divided into two parts. One is discrete, in which you have like whole numbers, 1, 2, 3, 4, 5. Okay. And then you have continuous, such as the number 3.265. An example of discrete and continuous data that I can give you is my age is a discrete number. Whereas, let's say my body temperature right now is going to be a continuous number, or even my height, that's a continuous number. It can take on a range of values other than whole numbers. And this visualization up here kind of shows the different sources that data can be generated from. You have third-party data from third-party services. You have smart TV data. So this is a huge privacy concern nowadays. Like TVs are very cheap nowadays. Like compare that to 20, 30 years ago, TVs were extremely expensive. One of the reasons TVs are so cheap is because TVs have a lot of tracking in them, in case you did not know. So smart TVs, that's why I don't really buy smart TVs. If I can help it, I buy a non-smart TV, and then I might attach my Apple TV or my Google TV to it, which has a lot less tracking. So most TV manufacturers, they have tracking built in. They collect your data, a lot of it. These TV also have microphones built into the remote. So you can imagine the maliciousness that can kind of take place, and then they sell you data, which is also why it's such a privacy concern. That's how they make their money, by selling your data. So that privacy concern aside, you have data generated on social media platforms. You have data from purchases on e-commerce websites, data from, again, CRMs, and data that you see on websites, and so on. So let's move on to the next slide. So now that we kind of have an understanding technically and theoretically about what data is, which is important, I want to ask you, what is data science based on what I've described so far and based on your own understanding? I'd like to hear your responses in the chat, guys. So what do you think data science is? Okay, Judd says analysis on data and visualization. That's a very good description. Studying of data gathered, that's also a good description. Collecting and evaluating data, correct. Interpreting user information and relating it back to for understanding, also correct. So sorting, cleaning, and analysis of data. So all of you have given correct answers, but how can that be? Some of your answers are different from each other. That's because data science is an umbrella term. It encompasses a lot of things underneath it, a lot of things that have to do with data. And I like to call data scientists as detectives, because just like a detective who's trying to solve a case, you're also trying to find clues within data. and you have to think a lot of the times outside of the box to get to the right solution, as we'll see in a bit. So all of you, like if you guys see the chat, those of you who have answered, all of you have given correct answers and very close answers. So like I mentioned previously, data is just about everywhere. Data is the new oil, whereas in the past 10, 20 years, I've heard this term before, and I didn't really give it much credence before I entered the data science domain. But before like 10, 15 years ago, uh, oil was the commodity which started wars. Uh, there's a very funny meme that if your country discovers oil, America will come to liberate you. And that meme kind of illustrates the point that uh, data, like that oil was highly valuable. And now it's actually data. And to just give you an example, the 2016 elections in the US, which affects pretty much all of the geopolitical landscape around the world, that was kind of, well, hugely impacted. Like a lot of votes were swayed because of data and voter manipulation. If you guys have heard the term or the name Cambridge Analytica, it's kind of a company that basically used or mined data from Facebook and then generated profiles of people and swayed people to vote a particular way. So just by using data, you can kind of manipulate people. If this sounds sci-fi, it's not. It is actually the case. And that very interesting tidbit aside, these are some other places that we kind of see data, and some of them you already are aware of. For example, sales. You're trying to sell stuff even in a traditional business. You might have a shopkeeper noting things down on a piece of pen and paper. But in the days of e-commerce, data is all digital. The biggest retailers such as Amazon, such as eBay, such as AliExpress, they are all digital. Credit and insurance, you bet, like they use data, like the amount of transactions that happen in a second are kind of astounding. No human can match that. And not only that, those transactions have to be secured, those transactions have to be verified, and in case there is something malicious going on, there needs to be detection mechanisms. So data science and machine learning and AI play a huge role in the credit and insurance sector. In terms of healthcare, you have disease prediction and effectiveness of medication. One of my very close friends, he's working in the healthcare domain as particularly as a data scientist and an AI engineer. So he developed an app which he sells to hospitals that predicts the duration that patients would need to stay in the ICU. So it predicts the minimum amount of time they need to stay. And uh, the purpose of the app was basically to make sure that the ICU beds were free, they were not being used up unnecessarily, and also that the cost to the end patients is almost zero. Well, not zero, but as little as possible. But funnily enough, most hospitals, they did not want to buy this application. Can you guess why? Even though there was benefit for both, overall there was benefit for all people, but can you guess why most hospitals were kind of reluctant to buy an application like this? Well, someone wrote PHI. I'm not sure what that is, Albert. Someone said tradition. Good guess. Data, uh, privacy policy. Okay. All of you have made good guesses. HIPAA, data tracking. So just to let you know, when you design applications for sensitive places where there is a lot of regulation needed, you can make it very secure. You can make everything run on premises. The data does not really have to leave a hospital or let's say even a government building. So the real reason was because the hospitals would be making less money. The hospitals make money by charging people for staying in the ICU and charging them a lot of money. When the amount of time stayed by each patient is reduced, the hospital make less money. So even though there was a huge potential for benefit for, again, everyone involved. Like, they only saw the short-term benefit of, the hospitals only saw the short-term benefit of making money. So yeah, that is a problem that we face, even with tremendous benefits. That's how the world works, sadly. But aside from healthcare, you also have marketing. Like, if you've ever registered somewhere, like logged on to a website and have gotten offers from that website that, okay, we have a deal, we have a sale, this is what's going on. No one writes those emails. It's all done automatically to people depending on your preferences, what you like, and again, data that they have access to from other sources. Another field which is very close to what I do as well, I consult in the domain of robotics, particularly smart robotics. I've worked on self-driving cars. So all of these also use data, and a tremendous amount of data. These domains run entirely on deep learning. Then you also have social media, and you know that, again, with the amount of personalized stuff you get on a feed, whether you use Facebook, whether you use Instagram, or most famously TikTok. Like, the interesting thing about TikTok is, like, most of you have probably used it. It was one of the few social media apps where you kind of did not really have a choice in what to follow or what to not follow in the beginning. It just showed you stuff, you just scrolled. So the interactability is very little compared to other social media platforms, compared to Facebook, compared to Instagram. But their algorithm, their recommendation algorithm was so good that even the biggest tech giants, like, everything is now a TikTok clone. Instagram is now, they promote Reels, which is again just another form of TikTok. YouTube has their shorts, again, short form video. TikTok, Snapchat has it. So everyone just copied it because it was so popular and so mind blowing. And again, it runs completely on data. Like, there is kind of no interaction. You are recommended videos that you will like based on stuff you already like, and based on that, you're recommended more stuff. And that's kind of still the reason TikTok is so popular. It's so popular, in fact, that the US is banning TikTok, again, because it's owned by a Chinese company, the parent company. But so many people use it even in government sectors that they are resorting to having to ban it. And for their national security, which I also feel is just fear mongering. Yes. And then in terms of travel as well, I travel a lot for work. I have to take flights, and all of the flights, the pricing, it's updated in real time. This kind of happens using data. When there's surges coming in, when there are a lot of people, the pricing goes up. Again, it's all done using data. So we saw a bit more about data, like, and a bit more about specifically about industries where heavily data science is involved. Let's take a look at the actual data science process. So what do you do as a data scientist in terms of your work? Well, the first thing is obviously to understand your business. You have a business, and, or let's say your boss, you work as a data scientist and your boss comes to you, and your boss will say, okay, I have this problem, I need you to work on this. Your first goal will be to kind of understand the problem, understand the background, and like a detective who goes around interviewing everyone for a case, you'll be looking at all facets to completely understand everything that's going on relating to the business. Because again, the goal is what your boss says. The goal is, again, you can have multiple goals, just like the example I gave you with the solution my friend developed for the hospital. Your goal could be to benefit humanity, or your goal could be to make money for the shareholders of the hospital. Similarly, the business goals are different from other kinds of goals. So you need to understand that. The second thing is to understand your data. Now, data can come in many forms. It can have a lot of biases. It can have a lot of hidden patterns. So you need to have an understanding of the data. You need to completely, I like to think of the data as a crime scene in a detective movie. Like, that is your crime scene. That is what you have to completely understand. Then you have data preparation, which I like to think of as dusting for fingerprints or trying to find patterns or clues in the crime scene. So in terms of data preparation, it can be cleaning, it can be handling missing data, it can be maybe even joining multiple data sources together. Um, then you have modeling. And modeling is basically when machine learning comes into play, where you feed your data into machine learning or predictive model or some other kind of model that helps in your analysis. And based on what the model tells you, you evaluate. Basically, you evaluate the model to see its performance, to see how well it tells you something. And again, this is a cyclical process. It repeats itself, and then you might deploy it. So, for example, every couple of every couple of years, Facebook completely redoes their recommendation algorithm. Not Facebook, sorry, YouTube, in case you did not know. So in the very beginning, YouTube's, the way YouTube would promote you, it was based on subscribers. So if you had more subscribers, then it would promote you. Then they changed the metric to how many likes you got. Then they changed the metric to the watch time. How much basically of your videos were watched. Based on that, you will be promoted more or less on, again, people's homepage. And then they keep changing it. Right now, I think the most popular meta or the most popular uh, array is like reels. So if you make reels, your channel will be promoted a lot more than regular videos. And that's why a lot of people on YouTube, even the biggest content creators who they don't really get a lot of money from reels. They're making reels because that's what the algorithm kind of wants. And you can think of it as them deploying different versions, testing it out, the entire data science process, verifying it, then deploying it, then after a few years, changing it again. So that's kind of what the data science process looks like. So what we're going to do now is we are going to solve a very simple data science problem. And this is going to impart in you a very crucial skill, a very useful skill that you can actually use to freelance and to earn money. This is kind of a small part of the entire data science tool set or skill set, but it's a very important part. And this is going to be a hands-on thing that I'm going to be showing you. And I would like later when you guys get the time, practice this on your own. And like I mentioned, you can earn money off it. It's such a useful skill. So to kind of give you the background on this, we have a company called DeltaFast, which is a startup company that operates in the business of manufacturing and assembling of commercial aircrafts. So the startup basically works to make aircrafts, both manufacturing the parts and assembling them, and then of course selling them to potential clients. And this company is new, just having completed around 2 years in the industry. Typical stuff for a startup. Funnily enough, nowadays every company likes to call themselves a startup. There are companies that have been around for around 20. There have been companies that have been around for around 20 years, and they still like to kind of call themselves as startups. So I don't consider them startups, but 2 years I think is fair enough to call them a startup. So the top level management, of course, has decided to have a high level meeting on the budgeting for next year. So as you're aware, every year for every company, they kind of have a review of their progress, review of their spending, and if they made profits, where they would like to invest more, where they would like to focus on, and if they lost money, to basically cut down on the losses. And what they've done is they have invited all the directors to present the area of investment in the upcoming financial year. So, and basically provide a small justification on the same. So essentially, in the meeting, all the directors have to highlight what they think are good areas for investment. So this is basically where the directors, they need to put the detective hats on, or more specifically, the people working under them, the data scientists, they put the detective hats on. So what are we supposed to do here? We now kind of understand the case study. Well, the task here is essentially to analyze basically the available airline data covering their operating costs, number of orders, etc., and design a dashboard using Power BI. So this company sells airplanes that we're aware of. They sell them to different airlines. So we are going to analyze the data from those airlines to see how they're using the planes, their demand, and so forth, which areas are more in demand. And we are going to create a dashboard, which is basically a term for visualization in Power BI. And the goal here is to basically determine the orders for different aircraft types and analyze the cost. So we are going to be looking, uh, we're essentially going to be looking at different aircraft types and different airlines, how much are they costing, how much they're making, look at the top 5 airlines that have the maximum potential for in terms of revenue generation. So where can we sell them more airlines, as well as analyzing the total freight in, freight out, passenger in, passenger out. So how much cargo, how much people are these airlines carrying, to basically get deeper insights into business profitability. So these are the 3 kind of core things we'll be looking at. And towards the end, this is what our dashboard will look like. So I just need 1 second to enable Power BI and share my screen using Power BI. So one thing that you guys need to kind of know, Power BI is basically Windows specific. Like there are a lot of alternatives that do the same thing. You have things like Tableau that also does the same thing, which is again, being able to create these visualizations and dashboards. But the thing with Power BI, and the reason why it's kind of so popular, is because it is completely free. But the downside kind of is that it's kind of only available on Windows. So it's great for students who want to learn, and since a lot of people, they have Windows machines, they are able to use Power BI quite effectively to learn. Whereas so interesting enough, I started with Tableau, which is another kind of, um, which is basically another, like I mentioned, a visualization software, and that was not free. And they don't even provide trial versions for students, which made learning for me kind of very difficult. So I just need a minute to share. So actually, let me know in the chat, how many of you actually have used Power BI so far, or have done any sort of other visualization? Okay, some of you have, so that is actually good. So let me stop the screen share here, and on my Windows machine, I have to switch. Okay, so let me share the screen for Power BI right now. There we go. So right now, my screen should be, it's in the progress of being shared. Yeah, so my screen should be visible to just about everyone. Do correct me if I'm wrong. So same here, Angel. So that's why I kind of had to switch to a Windows machine. I use a Mac as well, and since I am not really at home where my main Windows machine is, I travel using my Mac. But again, with like you have a benefit and a cost to everything. The benefit of Power BI is that it is absolutely superb for students or people willing to learn because it's completely free. But the downside is it's kind of Windows only. There are ways around it, but again, the easiest way I'd recommend is just to use a Windows machine. So this is basically the interface for Power BI. We are just going to create a blank report. I'm going to click this, and you can see that the interface has changed. For the data set in question, I'm just going to share it in the chat. Just give me a second to do that. Okay, so just give me 1 second to share it in the chat. Okay, I need to change it to non-host and panelist. So I've just shared the data. It should be in the chat. So there are a couple of files, 5 files in total, and the files are essentially called data.zip. All of you should be able to see it in the chat, data.zip. And this contains the files. You just need to extract the zip file, and you'll find all of the relevant files inside of it that we'll be using. So we will now quickly load up the data. Now, if you open up the particular zip files, and if you try to look at it, you will kind of see that the files are CSV files. So I'm just going to very quickly, it's in the chat. So the files are in the chat. You might need to go above in the chat, but they're in the chat and visible for everyone. You might need to scroll up. Yes, I have sent it. I can see it on both my machines, so it is in the chat. Okay, so we are just going to load up some data. And in order to load data here, you have multiple options. You can just use this here, import data from SQL Server. So, and there's also a tab here. So I'm just going to click on import data. And what I'm going to load is the CSV file. So text/CSV. Again, they're in the chat. You will need to scroll to see them. Like all of the data is in the chat. And to open it, again, it's a zip file. You need WinRAR or something to open it. Now, in order to basically, in order to, I need to open up basically, I'm going to show you what the files look like. So just give me a second to do that. So, and actually let me switch my screen view to the entire screen, share. So this is basically what the data in question looks like. You have aircraft type.csv, airline, airline port country, international miles, order cost, and total operating fleet.csv. So these are all of the files that we will be working with in question. So I am just going to select all of them, control. So actually there should also be an option to import from folder. Okay, so again, all I went was into .csv and okay, sorry, my screen is paused. I need to re-enable that. So just give me 1 second. So this is basically, my screen should be visible right now to everyone. So this is, can you see my screen right now? It should be visible to everyone. Okay, so these are the files in question, 1, 2, 3, 4, 5, 6. Okay, we'll be using all of them today. So I'm just going to load them one by one for simplicity's sake. You can see that after I clicked open. It is now processing it in the background, and you can now see that it is telling me, okay, this is data. It has two columns. It is a CSV file, and you have the option to load the data or to load and transform the data. So loading will basically load it for you to be able to use, and loading and transforming will basically allow you to process the data, to clean it up if you'd like to. For now, and you can do that later as well if you want to clean it up later. For now, I'm just going to click load. And it's asking me if I want to apply the changes. So as you can see here, it's loading right now. It's creating, again, it's creating a data model internally. And all I had to do was just click open the data. I didn't really have to do anything too technical. And how do we know that the data has been loaded? Well, you can see the data here as well. We have aircraft type. And if I go down here, I can see more details about this data. Just click this and you can see the data here as well. So I need to load more of the data. I had more files, so I'm just going to repeat the process for all of the other files as well. Airlines.csv. Again, I'm just going to load it. Again, it's making sure everything is up to par. Then I'm going to load it again. Third one is airline port country. And once again, I'm going to click on load the data, and it's just going to load all of the data. Now, all of these files are CSV files. These are files formats that, again, you can open in Excel or even a text editor. So they should open in any format. And these are some of the most common files that data scientists kind of work with. So let's continue until we've loaded all of them. So next up is international miles. And for those of you who are, it's fine if your Power BI is downloading, that's fine. You guys should be able to, again, if you just follow along in the video, understand what's going on, and you should be able to play along like when it's set up. And for those of you who are not able to open the file, it's a zip file. You need to extract it again using uh, WinRAR or WinZip, which you can install for free as well if your system does not really have it. Most systems can actually, if you use Windows 10 or even like any recently updated OS, you should be able to extract it without any problem. So next file is again order cost, and I'm just going to quickly load all of them. And one thing you might notice, I'm not really cleaning them right now, but you'll notice that some of them actually have missing data. Null, 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 null. That means some of the data is missing. So I'll leave that for now. Loading. And then we have the total operating fleet. So there are ways to select, again, load all of the files. There are ways to do it. To keep things simple, again, I'm not really trying to get into a lot of technicalities right now. So I'm just trying to keep things simple a lot right now, since the primary focus is how you will be using data to make the dashboard. But yes, you can actually load them all at the same time. And you can load, so just to let you know, interestingly, so these are actually all of the data sources that you have access to. You can connect it to the cloud. Like anything you can kind of imagine, you can get data from. You can get data from even like live websites. You can data from the stock exchange. And you will need to scroll up. Again, the data is there for everyone. If you cannot see it, it's because you probably need to scroll more. It's a file, or probably you've missed it. So now that I have kind of loaded all of my data, sure, you can install Power BI later. That's not really a problem right now. Just try to learn what we're doing and how we're doing it. So you should be able to follow along later. Okay, so what I'm going to do now is, now that the data, all of it is loaded. So just need a second. Okay, Sorry, I just need 1 second to do it. Okay. So this menu right here is basically what allows you to make most of your graphs and visualizations. So the first thing that I'm actually going to do is I am going to select this one right here, this visualization. I'm going to drag it here. And right now you can see it's empty. Something happened when I clicked it, but it doesn't really show anything. And the reason it doesn't show anything is because I have not really given it any data to kind of look at. So basically the first thing I want to show is the total order volume, and maybe I will actually use this one for it. So I want to show the total order volume. And let's see where the total order volume is. We have airlines. So here we go. So what we have here is freight in, freight out, mail in, mail out, order cost, orders, number of orders, the sum of all orders. So I think this one is probably the right fit. So we can just drag them here like so. And you are able to see. So what did I just do? So I selected the type of visualization I wanted. Again, it's a graph, and all graphs require a certain amount of data. Like what do you want to plot the graph of? So I wanted to look at the total number of orders, which is one of the requirements. So just drag this and put it here, like in the field, and it automatically kind of populated it. Now I can change the way this looks in any way I want, and we'll take a look at that in a second or two. Another thing that I kind of want to look at is basically the freight variance. So again, I'm just now going to click out. Now this is not really selected. And this time I'm going to select this type of visualization. And Jude, today we're not really going to be looking much into schemas. Again, that's kind of another topic in on of itself. Today, the focus is primarily on visualizations and how to use Power BI effectively. So in this one, I want to look at the total freight out variance. So this is freight out. And I can just select this, drag it here, and this is the value I kind of want to look at. So this is the freight out variance. And I have basically the total number of orders that have been kind of fulfilled, as well as the sum of freight out variance, or how much freight or how much cargo was carried out in a particular period. So the maximum is 17.16 million, maybe overall. And in this particular year, we basically carried out 8.56 million tons of freight. So one thing you might have noticed is that it does not really look appealing. For one thing, this name right here, it is not formatted correctly. So can we do something about it? And yes, we can. So all of the graphs that you see, all of them are completely configurable and editable. So in this case, I probably want to change the way the label looks. So I'm going to go in. So general, here we have title, and this is what the title is called. So I'm just going to call it, okay, it's freight out. I think freight out is enough. And maybe I want to move it to the center like so. And maybe I want to make it bigger. So heading 2, yeah. Let's see if I want to change the font, and probably I do. I could change the font to anything I like. I really like Arial Black. The font has also been changed, and I can change the font size. Now it's bigger and much more readable. In this case, Emerson, the data is not really coming from an SQL database. You can connect any database you like. But in this case, again, to keep things simple, we are looking at CSV files. So I think this is good enough now. I can change a lot of other things as well. So let's say I wanted to change certain colors. So I go to color. So this is kind of the fill color. So maybe instead of blue, I wanted it green. And well, I don't really see green in the initial menu. So that's not really an issue. Maybe I want a darkish green. So I think this color is perfect. And the target color, I'm guessing the area that's not really filled. So the target color is not really being used, so we don't really have to use it. Then you have data labels. Again, if I want them or not, target label doesn't really affect things because we don't really aren't really using the target that much. And the callout value, or the value we have right now. So I can change basically any aspect that I want of the visualizations I put in. Now, another thing that I want to look at is, and this one is one of the more beautiful, one of the more prettier uh, kinds of visualizations. What I want to look at is basically the locations of kind of the different airlines, or the count of airlines according to their location. So when you're dealing with location, you also have maps that you can use. So I'm just going to use this kind of map. So this one right here. And another thing, just to show you, if I already have something selected, for example, this is right now selected, and I think I should not really mess with this right now. I can just show you in another way. So let's say I've chosen this visualization and it's kind of already selected. So if I move on to another visualization, if I click something, it will just change the one that I've already selected. So I have to kind of deselect first by clicking out. Just a small tidbit, because this is very frustrating for initial users. So right now we are looking at the location, and I want to basically look at the location, basically the count of the airlines according to the different countries. So in order to do that, I need a couple of things. The first thing that I need is basically the country. So what we have here is the port country, and I'm going to use it as it is. So this is going to be the location right here. And one thing you might have immediately noticed is we did not really get any output. Well, we got some output, but that output is not really correct. Has it interpreted it correctly? I really doubt it, because we have kind of a fundamental issue that we will, yeah, these maps are kind of the coolest aspects. So this map is not really correct. It's not correct because the data we gave it, well, the data is okay, but the way it understood the data, because it does a lot of the legwork, it understood the data incorrectly. And the reason for that is you'll notice that all of these data points, all of these datas, they kind of have, well, there's something. Like, for example, you see this summation, which basically means like it's the freight in, like it's adding all of them up and we have the total freight in. And here what we have is, basically the port country. You'll notice that there's no label here, and that's kind of an indicator that Power BI does not really know what this column means. And you can see this here as well. Right now, this data category, or essentially the category, is basically categorized. We need to change this. So I'm going to go in back into port country. It's uncategorized. I need to categorize it. And I do not exactly recall what this was. So we can actually take a look at what this data is. So I'm just going to go to table view. This allows me to see all of the values. So I don't really need to go to Excel to, you can go in and see it. Sorry, someone is being really disrespectful in the chat. Ruby Borja, like, please keep things civil within the chat. If you have any concerns, you can type them out, but keep things respectful and professional. Otherwise, you will be removed from, again, this conference, this webinar. So this right here is kind of the port country. And going into the port country, if I take a look at it, we can see that it is essentially a list of countries right here. So now we know that it's a country. We can go back here and I can change the data, clicking here, and I can just select, country from here. So again, this is also kind of a confusing thing when people start out. You have county and you have country. So in America, certain regions are described as counties, but again, this is not a county. So this is a mistake that a lot of people make. So this is a country. So now that I've kind of selected country, you will notice that the logo here changes and it now reflects country. And these are kind of all of the locations. Again, this map is still not complete, but now that it's taking on the correct data, it's better. So now we have the map, we have the locations, but again, we need to fill the locations with something like what are we looking at? And the thing that we're looking at is basically the total amount of airlines or the count of airlines. So I need to look at the data again. Something I need to look at the airlines. So airlines, these are all of the airlines that you have and that kind of operate. So I'm just going to take this and the category is, sorry, I think I can just take this legend and take it to the legend. And what we have here are the different counts of the different airlines. And actually I can just move it to the bubble size. Yeah. So this is kind of a much better visualization. So these are kind of the different markets and port country. Let's see if it's correct. More or less, yes. So yes, this is New Zealand. Yeah, things seem to be in order. So table tools. So if you're asking about table view, again, these are the tabs that you can use to basically go to table view. So what you'll notice here is we have a map and the circles on the map kind of represent areas where where airlines operate, who we have or our company has sold planes to. And the bigger the size of the map, the bigger the size of the circle, the greater, basically the more airlines operate in this region. So the size correspond to the different, again, the volume of the different airlines. So I can just scroll here like this. I can look at the map in detail and I can also change the color. So I'm just going to leave things here for now as they are. I'm not going to change anything at the moment. So another thing that we would like to look at is maybe the freight in terms of tons by year. So whenever this is a piece of advice for all of you. And Kevin, since you asked about the e-certificate, you need to attend both days of the session and it will be automatically emailed to you. And thank you, Najala, for clarifying that as well in the chat. So whenever you're trying to show something according to time, again, now you want to look at maybe the amount of freight that comes in every year per in tons. So whenever you're comparing something by year or whenever you're looking at something in time, the type of graph you'll always want to use is a line chart. So again, I have this selected right now. First, I need to deselect it. I can just click out. I can just select this. And I have a new chart, which is a line chart, as you can see here. Now, in order to use the line chart, again, it will want some data. And a line chart, again, takes two data points. The first is the x-axis and the second is the y-axis. So what I will be doing here, again, since I want to look at the total freight in, where is the freight in? Here we go. We have the freight in here. So that will basically go in the y-axis. Again, typically the standard is that the x-axis is reserved for time. And I can just take in the year and the year is going to go into the x-axis. So this is basically the volume of the freight per time, like according to the year. Now you might, again, if you put on your detective hat, you might be able to notice, you might notice that the trend was that the total amount of freight or is going up year over year. So in 1985, the amount is very little, but as the time goes on and on and on, you will notice like it keeps going high, but around this point, it goes down very sharply. What happened? Is the company going bankrupt? Like, why do you think this happened around this time? So what year is this? So in 2018, it's still up. In 2019, something happened and it just went downhill after that. It went down, 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 and then we have the latest. Exactly. You guys spot on. So this is again where you put on your detective hat, where you think of possible reasons why something could kind of happen. So most of the ups and downs are cyclical. So they repeat at kind of a cycle. This is something that is kind of an outlier. It's something out of the regular. There can be multiple reasons, but we know the reason what happened in 2019, that was COVID, where flights, no one was traveling. Airlines were kind of going bankrupt. I do remember was it American Airlines? or was it another one which I forget? I think the US government bailed that airline out because they went bankrupt. And how did the airlines manage to not get bankrupt? Well, initially, a lot of them did. They were subsidized, but after a while, they started actually shipping products instead of people. And that's how they were able to make some money. So this is done as well. So maybe I want to look at another thing. I want to look at the total cost per airline. And actually, let's actually look at uh, the amount of freight in and out according to the port country. So I want to compare two things, and these are tabular things. So I might actually use a table. So these are kind of all of the visualizations that we have access to. I'm going to use the table right here. And this table, of course, expects certain values. So what are the columns that are going to come into play? And in this case, the columns that we will kind of be looking at, and actually maybe instead of a table. So again, just to let you know, you have multiple options in terms of how you want to visualize things. So actually, instead of a table, I might be using something different. I might be using a stack bar chart. So this is a clustered bar chart. This is a regular stack bar chart. So I think a stacked bar chart. Okay, a clustered bar chart is okay. So for the X value and the Y value, so for the X value, it will be, yeah. So on the Y axis, I will have basically the names of the countries. Since it's vertical, okay, so it's a category and I want to look at the countries. So I'll again use the port country on the y-axis. And again, it's not showing anything right now because again, we need to complete the entire data. And then I want to show in the total passenger in, passenger out. So let's say I want to look at the freight in here and I put that in the x-axis. And what you'll be able to see is what I have is essentially countries along with the freight that's going in and out. And okay, there we go. And maybe, so now we have an idea about the total freight in and freight out according to the country. And for that, I basically use the stack bar chart. Okay. And I can zoom in and out. I can look at all of them. We can see that Singapore is kind of the biggest client here. Singapore is the one that's having the most amount of freight come in and freight go out for, like, again, our particular planes. And I can change them as I want. Maybe I need to do a few more things and then I can just simply clean up things a bit. So I would also like to view the cost per airline in terms of like maybe a tree chart. So that kind of helps you get an idea of the cost. So I'm just going to select out and I'm now going to select a tree chart, which is right here. And I want to look at the basically the total cost per airline. So the categories are the particular airlines. I'm just going to select this. These are the categories. And then I want to look at the cost. Okay. And actually I can just come here, I can link a couple of things together. So if you have certain tables and there's a certain relationship between them, you can link them together. And the two kind of columns that I am looking at in my data right now. So these are again the data model view of our data. Okay. So we are looking at basically the airline, and with the airline, I am interested in the total cost. So there are always things that kind of overlap. So aircraft ID, you can just match them together. And in this case, no, flight number here, no, not here. Okay. Country, future flight. Yeah, total flight number, total operating fleet, and the airline number of airlines. Actually, I can just use airlines from here. We have it here as well. And I have the flight number, and okay, yeah, here we have flight numbers. So I can just drag this to here, and again, both of them have slight amount of overlap. I'm going to apply, and this will basically allow me to use different values from different columns if in a very simplistic sense. But again, not going into too much detail right now, but basically what I wanted to do is the total cost is here, okay, which I wanted to use. And I also wanted to use the cost per airline. So I'm just going to remove this airline. I'm going to use the airlines from the international miles right here, like so. And I'm going to select the total cost. And this would probably be the value. And the details, okay. So let's take a look at something is wrong with this particular visualizations. We only see two. We see JetBlue and we see American Airlines. So there can be many reasons for that. Actually, should I use total instead of total current? I think it should be total. No, it's still that. I think it has to do with airlines. So I think I can cluster them together. It will automatically figure out and cluster them. Okay, it's uncategorized. So this is not really data. And we don't really want summarization. That's fine as well. I can just actually use this from here, category. So what we have right now is basically the flights or the different models of planes and along with their frequency. But this is not really what I kind of want to look at. Actually, this is not really giving me a good visualization. And again, a lot of times you try different things out and see kind of what works. So category airline, and I can just look at out, fade in, fade out, and I can just look at, let's say, passenger out. This kind of does give an approximate to us for, yeah, Qatar Airways, Singapore Airways. So this does kind of give us an approximation of which flights used kind of had the most volume and thus their cost or their revenue. And yes, Power BI can report on real-time data. You will just need to connect to a real-time data source for those of you who are kind of asking. So if I go back, actually, I need to select out. Here, if you get data, you can collect your database that's been updated in real time. I can connect to a website. For example, I can connect to the stock market, like the NYC New York Stock Exchange or the London Stock Exchange, and I can get real-time data from there, and I can make any sort of visualization that I'd like. Another thing that I want to maybe visualize it is actually a story, Milton. So we had a couple of questions that we needed to answer in the beginning. So in the beginning, we asked a couple of questions. And the questions were, where should we invest most of the money? A couple of things that we specifically want to answer the questions, but the general problem was that we wanted to know where we should invest most of the money for next year to essentially make more money, to get an idea of things. And we will kind of get into that in a bit. So the final thing that I want to maybe visualize is the total cost per airline. And okay, and I can maybe use, and I also wanted to show you, I also want to basically show you stack chart, area chart. Yeah, the different kinds of visualizations that are available. So it's kind of a multiple fold kind of problem that we're trying to tackle right here. So I will use, so I want to look at the cost by airline. I can just use the total cost. And I'll put this in the y-axis. And need to do it by the airline. There we go. Yeah, it's just showing me two of them, which is kind of weird. Okay, let's see if there's something problematic with the data view. I'll just delete this. Yes, delete the relationship. Okay, let's try to tackle in what could be the problem that's not allowing us to visualize properly. So I just want to look at the airline versus is popular. It's possible that the two columns do not contain the same value. Okay, so what we can do instead is flight number is here as well. I could just do flight number here. And order cost, data import, many to many, both active, yes. So if we go back now, and okay, now I have this y is basically a total cost, and I need to compare it basically to the airline, and I'll put that in X. There we go. Now it's perfect. This is kind of what I wanted to see. Certain columns have different values, which is why the visualization was slightly different. So in this case, these are, again, this is not really the best visualization for this. Like this is also a point I wanted to make, which is why I chose this specifically. Can anyone tell me why this is not really a good visualization? Why using a line chart is not really a good in this case? For those of you who have used these charts before, who have done visualization problems before. Any guesses? I'd like to hear them in the chat. Yes, it's not easy to digest. And also, yes, X has a lot of values. So the more technical reason is, and you learn that as if you, again, as you get more involved in the field, is because typically in terms of line charts, you don't really have categorical values. You have continuous values. So these are categories. If you notice here versus here you had continuous values, you had numbers. Here you have categories. When you have categories, the better fit is to use a bar chart. So I'm just going to switch this again. I have this selected, and if I select anything else, so let's say I select this one, it will change to a bar chart. And this is much, much better. So do you guys think it's better or worse now? So what do you guys think? Answer in the chat. Okay, it's better. Perfect. So again, these are things that you learn to pick up. And yes, you can flip them as well. You can flip the X and Y axis by changing the chart or by flipping the values. Again, if you flip if you want to make it horizontally, then you'll also need to flip the values to make it not look bad. Okay, so let's actually put our detective hats on again, and then we'll finally clean this up a bit. But I want you guys to kind of tell me right now. It seems like we did 9,194 orders in total, which is kind of good. And we made 8.58 million sales, which is actually not good. So we can see that the sales from, maybe this is from last year. So the sales from last year are not that good. Okay, so as someone who wants my business to make a lot of money, okay, why haven't we made so much money? So I try to investigate. I try to look at basically over time how much freight has come in, and I see, okay, okay, this year we have actually gone into a loss. We have not been shipping a lot of things out. Since we, again, data scientists, we use our brains, we know that it's because of COVID. Okay, so COVID really like messed up our sales. So we actually have lost money. So, okay, what can we do for next year? So we might need to do an analysis on the different markets. So we might need to look at the markets and see where are the markets that are kind of the most active that are also buying the different planes. So we see here that's New Zealand right here actually is buying a lot of planes from us. Australia is non-existent. Maybe that market is kind of dominated by other players. And here we have Singapore. Singapore is also kind of a big market for us. So you might notice that there are bigger circles and smaller circles. And let's zoom in. So we have Malaysia and Philippines should be here. Here's Philippines. So for Emerson who asked, so one way we could make more money is to focus on these areas of interest. So these regions which actually do account for most of the money made or most airplane use. So if we, because they use a lot of airplanes, if we try to sell them more, again, they have the demand, so they can buy more. And because that makes sense, right? Because they have a need versus, let's say there's this one small island, and I don't know where this is. This is Timor Leste. I have no idea where this is. Actually, it's near next to Indonesia, East Timor. So the demand here you can see is very, very minute, and that might correspond to the landmass again. Um, so trying to sell them, let's say they already have 10 planes, and again, they probably use them, but the demand is not there. So if I try to sell them more planes, if I try to invest money into sales, if I send people there to sell more planes, again, because they don't have a demand, they're not really going to buy more planes. So it makes more sense to go to maybe New Zealand because the demand is so high, to the USA because the demand is so high. Yes, again, you can make any sort of visualization. Actually, this is kind of the visualization. We don't have data for the demand directly. So we don't have data for the demand directly in this data set. So we are kind of looking at the demand indirectly, Jude, by looking at how much is the usage. So the more you're using something, the more you need it. For example, uh, computers. There's a demand for computers in schools. That's why they buy a lot of computers because, again, students need to work on computers. Uh, Most universities and colleges, they buy a lot of computers in bulk, and that's also why they get a good deal. Like in the US, I think it was, before it was common to get iPads for like school children that were given by the schools. Afterwards, it was MacBooks. So again, you need to focus on where the demand is. And if we, again, this is like the bird's eye view. Now, if you want to zoom in even more, we can see, okay, that these are the regions of interest. So the highest amount of freight that is going in Singapore. So maybe again, and Singapore is a very big transit junction. Maybe investing in Singapore and New Zealand is kind of the best bet, followed by US. Maybe US has a lot. US, we do know again from our knowledge that US is a very big market. US has a lot of room to grow. So maybe again, we can target here to again continue our sales here, but we can maybe also focus a lot more on the USA because we could like gain a lot more clients there and sell a lot more. And similarly, the Malaysia is also a very big potential target. Like it's not as big as New Zealand and Singapore, and maybe we should change that. So maybe next year this company should spend time in investing and again, its marketing budget in these particular countries. So these are the country wise. This is the country wise breakdown of where again this most of the sales are coming place. But what about the airlines? Because that's actually the airlines that operate this stuff. So you can see that Qatar Airways is kind of the biggest. And here I looked at the passenger out, and maybe actually I should switch to, because I do remember this data stuff was not really correct. So we have passenger out and airline. Not really what I wanted to look at. I wanted to look at the total cost and the airline. So I can use the airline as it is. And instead of the passengers, I want to look at the total cost, like so. So there we go. This is, yeah, the more accurate graph, the correct graph. So we don't have the data, Milton. You will, to answer those questions, again, questions get more questions, and to answer those questions, you might need to look at more data. You might need to look at sales metrics, look at how many, what is the market share of your competitors. So again, all of these questions are answered by data, and we're right now working with the data we have. Like if this was a real, again, this is actually a problem that does occur in real companies. So what would happen next is you would ask for more data, you would try to get more data, relevant data. For example, let's say you're interested in Singapore. So you look at what airlines are flying there, how many planes do they have made by a competitor versus us. We look at our sales number, how are we trying to sell to them? Like you look at all of these different things. So we can see that American Airlines is the biggest um, um, buyer for us. In terms of total sales, we have 1801, followed by United Airlines, also American. Then we have China Southern Airlines, which is cheaper, which is within Asia. And actually, another thing you might notice is that most of our business, or most of the money that this company seems to be making, is within the Asian region. We haven't really expanded much in North American, so maybe it would make sense to try to dominate the market in Asia. Because Asian markets are, if I have to give you a reason, because Asian markets are also developing markets. It will be a bit more difficult to actually try to get a foothold into America because they have Boeing and the other manufacturers. And of course, trying to get into an established market is much more difficult than trying to get a clientele. And since we're a startup, we want users. It's much more easier and cheaper to go into developing countries. So I'm just going to very quickly clean some things up here. And I've already showed you this. So again, I don't really like the way the title looks. So I'm just going to change this, go to general, and actually I can change a lot of stuff. I can add a zoom slider. I don't really need that. Shade area, that makes it look cooler. So we're going to do that. I can add the markers, not really needed. And also this also makes it cluttered. So I'm just gonna go here. I'm going to go to a title. The only thing that I think needs to change, freight by year. There we go. And I'm just going to move it to the center like so. Likewise, I want to change this as well. It is very, at least the title is very ugly. I'm going to be very honest. I can also go here visually. I can change the style. So maybe I want to make it grayscale. This is what it looks like in grayscale. Not very pretty. We have light. So we have different styles. We have, what is Arial? So again, much more realistic, but a lot harder to also tell. So I'm just going to maybe switch to light to keep with the theme. We have bubbles and the ranging is set to auto. I can adjust the range if I want to see something more prominent and if I want to use a heat map. Right now I don't, like bubbles are fine. So I'm just going to change this here. So airlines, I'm just going to change it to airlines. Like so. And I'm just going to move this into the center, like so. So there we go. And I'm just going to do the same thing here. And I'm going to rename this. So this is basically freight n/out by country. And again, I'm just going to move this to the center like so. And maybe I don't like the color and I'm feeling it's dull. So I might actually change the color to, let's say, yellow. There we go. Okay, what else is remaining? So again, this as well, I want to center it. So I will center it and I will call it, this is basically airline share by airline, or planes by, so planes by airline. So how many planes are possessed by which airline? Likewise, I go here, moving this to the center. And in this case, I wanted to look at, this was basically total cost per or airline. AIRLINE. There we go. All perfect. Since I'm a perfectionist, I'll just make this caps and there we go. So I will maybe change a few things. So I can change a lot of things. In this case, maybe I want to change some of the visualizations. So minimizing this, the height is fine. I'm just going to go with the visual aspect and I want to look at the columns. So I can change the color of the individual column. So maybe let's say I want to highlight, for some reason, I want to tell my bosses to invest in American Airlines. Actually, let's say China Southern Airlines. And the reason for that is simple, more room for growth. So I might actually color it a different color to highlight this. And you can see now attention is being brought to this. And one interesting thing that you might not know, these graphs are interactive. So if I click on them, it will automatically update to show me where things are operating. For example, in America, where we have a lot of total like cost, like it's only American airline. And again, actually, no, this is we're selecting the different airlines. So if we look at China Southeast, so again, it's mainly operating in China. This is the region, this is how much freight and carried in, and this is the volume according to the year. If you look at America, again, we can see this is a trend. So actually, our sales have been very pitiful, like from 1992 to this. It seems like our company only recently started to do sales again in 2015. And it seems after the pandemic, after in 2019, actually, our sales, like they dropped for a bit, but here the sales actually went up. And I think it's because America was importing a lot in bulk, the mass and stuff. So this is basically how um, yeah, this is basically how you find different points, or do you find things of interest. So this is basically what we, this is a dashboard that we wanted to make, and this kind of gives us an idea to answer our questions. So I'm just going to quickly switch over to the screen share. I'm just going to quickly switch my screen sharing. Like this, we are done with the practical dashboards, and I'm just going to stop the share here. And I'm going to switch back to the slides now. I just need a second from you guys to be able to switch. There we go. Full screen. So this is the visualization that we saw basically in the slides, and you learned how to make it. Okay. And if you remember, we had a couple of questions. What are the top 5 airlines that have the maximum potential revenue generation? We did that. The first one was American Airlines, followed by the second one, which was United Airlines, and the third one was Chinese, like the Chinese Southern Airlines. I don't remember on the top of my head what the last two were, but uh, you can see that here. I cannot read it, but we actually made that. The other question was determine the orders for different aircraft types and the total cost. We looked at the cost, and we actually also looked at the orders according to the airline. So we also did that. And the last thing we wanted to look at was basically to analyze the total freight in and freight out, passenger in and passenger out, for essentially getting deep insights. And we saw which countries have the most potential. We saw in America, we're not really again selling as much as others, but we also saw that because it's a developed market, maybe it's not really the best idea to start there. Maybe trying to establish dominance or capturing the Asian market is a good start, and then expanding there can be like a better idea. It's kind of like with Uber. So in case you did not know, Uber started only in America, then it expanded to other countries, including like Europe. I think the first country in Europe it went to was London, or the first city in Europe it went to was London. And at that time, Uber was not really legal. You needed to get permits. So even that is kind of a very funny story. They only started experimenting in the Asian markets, like after they had captured the European market. So they had kind of established themselves, but they weren't able to capture the Asian markets. So they tried in China. They actually spent $1.5 billion in total, but they kind of failed in that. So we kind of looked at what the dashboard said, but I want you guys to tell me, is Paul's like this dashboard informative? Does it basically inform business decisions? Does it actually inform business decisions and allow us to basically make informed decisions for the business? Please let me know in the chat. Okay, good. And did you find the process of making it interesting and cool? Okay, great. So actually, sorry, I need to share the screen again. Okay, so now you see kind of how data is the key growth driver for any business. Like now you see how data is important. And if you do agree, again, please give a thumbs up in the chat. And interesting enough, I told you before that this skill is a small part of the data science umbrella. I mentioned that just by learning this one skill, you are ready to kind of make money. And this is a very popular freelancing platform called Upwork. And if you look here, like the demands are to make dashboards, which kind of you have done. It's a business, like the requirement is to make a business dashboard like this, and you can essentially charge anything from 500 to $1,000, depending on your, again, depending on how much data it is, how much connections, how much cleaning is required, and the amount of work, and also depending on how much work you've already done on these platforms. But you can start earning money using what I just showed you. And like you just saw, it's not too complex. Like all I did was dragging and dropping. Personally, in my personal work, I don't use Power BI too much. Like I rarely touch it. I work mainly in Python. Like I mentioned, there are 100 ways to do the same thing, and depending on the kind of work you do, maybe things are like different things would be a better fit. But like this is very easy just to get started. Power BI. And now you also kind of understand how valuable this skill is for companies. Building dashboards, essentially, like I mentioned, is just one small thing in the data science umbrella. It's you learning one skill, which is data visualization. And even in data visualizations, there are a lot more other things as well. And there are many other extremely valuable skills that you can kind of learn and bring on board as essentially a data science professional. Okay, sorry. So they can kind of bring on board as a data science professional. And actually, sorry, let me configure something for a second. I need 1 second to do that. Okay. So, like I mentioned before, it's just one small skill in your entire tool belt. So you can kind of imagine the earning potential that you kind of get here. Okay. So moving kind of on, this was kind of the first time that you looked at this particular concept, that you saw how to work with data, that you saw how to visualize data. And it's not really expected in the first go for you to have learned anything. There'll be some things that are confusing the first time around, and that goes with any skill in life. If you have understood kind of this concept, even like one new concept from what I showed you, even one thing, then that is kind of progress that you have made towards your journey. Now, kind of imagine if you learned 1, 2 skills like this every week from different industry experts like myself. And so once you do this every week on week, so again, it's like practice and kind of stack up your work, the work you've done, it also becomes your portfolio as a data analyst, which you can then actually show to recruiters or even like in freelance, like you can show your portfolio and get more money for the work you do. It helps you basically land interviews faster and even sail through them like a breeze. And that's kind of the differentiating factors between you versus your competitors. Like most of them don't really have good portfolios to show. You can also upload these assignments as work samples, like I mentioned, on Upwork and LinkedIn, which kind of improves your credibility. It shows people that you know your stuff, you know how to do stuff, and they should trust you with doing their work. So, what do you guys think? Does this look exciting? Like, are you guys interested in this? Okay, that is kind of perfect. So, kind of remember that Zaltius has helped dozens of its students to become exceptional data analysts and people who have kind of started their career within a period of like 6 months to kind of a year of starting this journey. And this is kind of one of the students, Josh Risulu, like who worked with Exaltius, and this is kind of the dashboard that he developed. He worked as a civil engineer in the beginning, which is a very different field from data science. Like you don't really program much or code much or even work with data much as a civil engineer, but he made the big jump and he was able to find a role that kind of fit him. And similarly, here is like another dashboard prepared by another student, Paul Kenneth, during who, by taking this course, was able to kind of transition his career. And sorry, and I will just move on. And here's another student who kind of did the same, like in terms of his work. Like he transitioned from like working in his regular day-to-day job, and again using the same skill, he was able to find relevant roles that are available for him. And these are kind of, if you once you go to the higher levels, these are the kind of visualizations that are kind of possible. So what I'll do now is I'll hand.
Yes. So guys, those of you who were part of yesterday's class, you might remember we took a swing at trying to visualize a real world or a simulated real world problem. And we made very exciting dashboards, and I hope that you guys, some of you did share your work, but for those that didn't, I hope that at least you gave it a shot. Because again, like we discussed yesterday, it's a skill that, well, you can start making money with from the get-go. And it is, like I mentioned yesterday, it's also just one small part in the data science toolbox. So that might make you wonder, if that's one small part, what are the other parts? Well, data science is comprised of multiple different things. You have databases and managing them using SQL. You even have work using Microsoft Excel. Like even that is a skill that data scientists do need to flex. And one of the biggest, again, tools in our data scientist arsenal is the use of the programming language Python. So I personally do everything in Python as part of my work. And what that means is I don't use Excel. Everything related to Excel, I can do that in Python and much more. Everything related to machine learning, data cleaning, everything I handle in Python. But again, depending on what you guys are interested in, depending on the kind of work you're doing, you might need different tools, and that's fine. So today, to cement our understanding of Python and to take a look at this second tool in our arsenal, we'll be looking at actually a real world problem, which is the prediction of houses in California. So you guys will be working with machine learning today, and we'll implement our first machine learning algorithm, which I assume is the case for most of you. So we have a company or a business known as Sunshine Realty, and they want to, since they're a realtor business, they want to be able to predict the houses or the prices of houses to offer good deals to their customers and obviously to price their own houses competitively to make good profit. Let me actually enable a slideshow. So the problem statement that we will be working with today actually is that Sunshine Realty, it's a prominent real estate agency in California, as was apparent again from the description of the problem. And the goal is to predict the median house value to empower its clients with data-driven insights for buying, selling, or investing in properties. So they kind of want to predict the prices, maybe to create a catalog to enable their clients who are paying them a lot of money to make good decisions. And the agency recognizes the importance of leveraging advanced analytics to be able to do this, to navigate the dynamic housing market landscape. If you had to predict the prices of houses manually, you might be able to if you were experienced in the market, if you lived there, if you'd been working in the field for a very long time. That's what we call experience. But for most of us, that's not really the case. And that's where tools like machine learning and deep learning come into the play. So a background about the company whose case study we're working on, Sunshine Realty kind of operates in California's diverse housing market, where the prices are influenced by a lot of factors, which includes the location of the house, the characteristics of the house that include how many rooms there are, and other economic indicators. California, as you might know, is a beach state in the US. So some houses might be located near the beach. So of course that would make their prices go up versus those that are a lot in inland. And the goal of the agency is to provide their clients with a reliable estimate of the median house value to, again, for the customers then to make informed decisions. So we understand the problem. So what's kind of the objective for us? So we will be working with machine learning, like I mentioned before, and what we'll be doing is to develop a predictive model that can very accurately estimate the median house value based on a lot of key features such as location coordinates, the longitude and the latitude, the house characteristics, which include the median age, the total number of rooms, the total bedrooms, and the number of households. So, as well as the demographic area and other socio-economic factors such as what is the median income of the people living in the area, as well as the proximity to the ocean. So these are the very important parameters that kind of influence the price the most. So this is kind of a description for data before we actually join in. So the data set provided by Sunshine Realty includes the following columns. So it's a CSV file. We have the longitude and the latitude, and as you guys might be aware, that is used to basically predict, that's basically used to tell where in the globe someone is or something is, in this case, where the house is located. Then you have certain features relating to the housing itself, for example, the median age, which correlates to the average age of the houses in an area. And you also have the total number of rooms. And the total number of rooms, basically, that corresponds to the average number of rooms in a housing unit. So if a house has more rooms and it's also big, it will, of course, cost more money versus a house that has just one room. Then we also have a total number of bedrooms. So there are different rooms. So that we also have a total number of bedrooms. Then we have a total population. So what is the overall population that kind of lives in the area? Most people, they don't really want to live in a neighborhood that is too overcrowded and overpopulated, because then it's a lot of fuss and a lot less peace. So that also plays into the pricing of the houses. You might have noticed most of the most expensive houses in whichever country you take a look at, those houses would be located in very peaceful areas where the population density is not too high. And thus the housing prices are relatively more expensive versus those areas where, again, the density is a lot high, and as a consequence, the prices are lower. We also have median income. So what is the average income of the people living in the area? So that's also definitely going to play into the pricing, because if they're rich people who live in a particular area, then of course they are going to maintain their or spend more money on the maintenance of their houses on their neighborhood, and that makes the prices of those houses in that neighborhood go up. Versus if you are in, let's say, a slum, the prices of the houses are very cheap, but as, again, people don't spend money, as people don't have a lot of money, they don't spend money into the repair, maintenance, and work of the house, which again makes their condition a lot more deteriorated, and as a consequence, the prices, they go down. And then we have ocean proximity, which kind of relates to how far is the house from the particular from basically the ocean. So there are four categories here. We have near bay, we have island, we have near ocean, and inlet. So near bay means it's very near to the bay. Near ocean means it's closer than near bay. Inland means it's like it's far from the ocean, maybe 3, 4, 5 hours driving. And island means it's actually on a small island that is off the coast. So what is the expected outcome for us? The expected outcome once we actually do develop our model is again to have a good model that will predict quite accurately what the clients want. Uh, and what the client want is basically the median housing value. And this will, again, once they know the prices of the houses, they can then pay the appropriate amount price and invest in wherever they want to invest or buy wherever they want to buy with the knowledge. So the problem statement kind of clear for everyone so far. Like, is there anything that's not really clear about the problem statement? Okay, so what we'll do now is I'm stopping the share for a second. I'm going to first share with you guys the data set in question. So give me a second to do that. So I'm sharing in the chat the particular data set. It's a CSV file called housing1.csv. It's supposed to be housing.csv, but because I had two copies, an older copy as well, it got renamed to housing1, but not really an issue. So the data set has been uploaded to you guys's chat. You can take a look there and find the data set. Now I'm going to share the screen again. So just give me a second to do that. So my screen should be visible to everyone right now. This is where we'll actually be coding in Python today. And I'm glad to hear, Samantha, that you enjoyed yesterday's workshop and that you are like excited for today. So this is basically known as Google Colab. It is an online hosted version of uh, Jupyter Notebooks, and it's a website that you can go to. You can just log in using a Google account. It's by Google themselves, and you don't really need to download anything. So I have done a lot of work before, which is the reason that I have a lot of prior notebooks that I worked with. But for our case, we're just going to open up a new notebook. So you need to go to collab.free, like just search on Google Colab. It will take you to the link. And you don't really, the good thing about this is that everything happens in the cloud and it's completely for free. You don't really need to pay any money. Uh, I'll share within the chat once more the CSV file and as well as like, okay. So my Collab notebook has opened. It's completely empty as you can see. So the first thing that I'm going to do is I'm going to rename them. By default, it gives it a name, Untitled 29, because I have 28 untitled notebooks, and that makes it very hard to find what you're looking for. So I'm just going to call it workshop day 2. For you guys, again, it will be more descriptive to name it simply linear regression, but I have more than around, I think, 50 notebooks just relating to that on different topics. So workshop day 2 helps me remember what this is about. But again, having descriptive names is really going to help you in the long run. So you can see the interface right here. The first thing that I'm going to show you is that you have two kinds of cells within within Google Colab. The first one is a code cell, which you can see here, and this is where you write the code. The second one is the text cell, like you can see here. And what the text cell allows you to do is it allows you to write text. So Colab will know that, okay, this is not code. I'm not really supposed to run it like code. So what do I want to write here? So the first text cell will be importing the libraries. So I'm just going to move it up. There we go. So the question I have for you guys is, how many of you know what libraries are in Python or any other notebook? Can anyone tell me? It's perfectly fine if you guys don't know. So perfect. So libraries are code, are pieces of code that other people have worked on that you can use for your work. Okay. And it allows you to not have to do something again and again and again. Because if someone else has done it, you don't really need to do it again. It simplifies your life a lot. So it's like this, like, don't invent the wheel twice. If you can find a solution, work on top of that rather than actually trying to, again, um, just to kind of illustrate the point, how many of you like sandwiches or eat sandwiches? It can be, again, a chicken sandwich. It can be a sandwich with peanut butter and jelly. So, do you make the sandwich completely on your own? And by completely, I mean, do you like first plant the mm, uh, the the maize or the barley or whatever kind of bread you like to eat, because bread can be made using different ways. But do you first grow the crops, then harvest them, then like grind down the grains to to make flour, and then from that flour do you make bread? No, most of you will probably buy bread on your own. Why don't you do that? It's because, well, it's if you can get something from somewhere else, you get it from there rather than spending your time. Similarly, if you wanted to make a chicken sandwich, so what do you do? Do you take an egg? Then do you put that egg in an incubator, try to raise that egg until it hatches, then again taking care of the chicken for 8 to 9 months until it grows old enough for you to, well, butcher it. Then you need to clean it, then you need to sell it. No, you guys don't, because that would, again, you'd be waiting for 8 to 9 months for a chicken sandwich. And interestingly enough, there was actually one guy who did this. He made a chicken sandwich from scratch. So he grew the crops himself, made the bread from those crops. Like, he raised a chicken from an egg. He, even for the salt that he needed for, again, marinating the chicken and stuff, he went to the sea, to had to buy a plane ticket because he lived very far from the sea, had to get the salt from there. And all in all, can you guess how much it cost him to make one sandwich if he had to do everything himself? Take a guess. Yeah, it's insane, yes, but it proved the point of how dependent we are in today's supply chain. Like, if we had to, like, if something happened and the supply chain was destroyed, like a nuclear apocalypse or something, like, we would be screwed. So yes, thousands. He had, so for one sandwich, two pieces of bread, kind of sandwich, he basically spent $1,500. And yes, he cannot scale. That's also another reason. So it's far cheaper. The lesson is, it's far cheaper to build your work on someone else's work than from starting from scratch. I think it was one, maybe more than one. I do not recall that. Like, you can search for the video, it should be on YouTube. So, as like, again, that lesson aside, now you kind of understand the importance of libraries. So really important, some of the Zenith Ismail, I'm not sure what permissions for you are kind of popping up. I'm typically, when you open Colab, so I'm just going to search Colab here. Again, it will open this. It opens this window by default. You might need to again log in using, you need to log in using your Google account. This is the Google service. It's completely free. And again, you just need to open a new notebook. So this is what you need to click. So again, I'm going to just close this window. And the first thing we do, like I mentioned, is import the libraries. So the way you import the libraries in Python is, again, one of them is importing NumPy as NP, importing, again, so you have a very useful autocomplete AI assistant here, which makes your job a lot easier, but I'm not going to use it. NumPy as NP, import pandas as PD, import dot plot as PLT, as SNS, from sklearn import datasets slash linear model. It's all in the browser. So for those of you who are wondering, it's all in the browser. Colab is completely online and in the browser. So, and that's kind of what I would recommend for those of you who are starting out. And so, because it's a lot easier than having to set things up on your computer when you're learning things out. Metrics, there we go. So I'm going to go over each of the lines and explain what they do. np.random seed. Okay. So I've imported a lot of different snippets of code from a lot of different libraries. So the first one is NumPy. So NumPy is kind of your best friend as a data scientist. Okay. You're going to be using it quite a lot. If not directly, then as part of some other library, such as pandas. So NumPy it deals with arrays. It is very good with calculations, computations, and is very fast. A lot of libraries are built on top of NumPy. So you will, for sure, anything that you're doing, you'll be using NumPy in one way or another, maybe to find the mean of everything all at once. But NumPy is something you're always going to be using. Then you have pandas. So pandas is basically Google Sheets or Microsoft Excel, but in Python. And it's much, much more powerful because you can feed it as big data sets as you like. It will not really hang or crash like Excel. So I do everything in Python in my daily day-to-day work. When using pandas, I rarely do I touch Microsoft Excel or Google Sheets for work. Again, I might have my own project that I'm dealing with, which I might need to use Excel, such as if I'm tracking how many books I've read and the like. Then you have, yes, Lovers, Mahangi, Mahangani. Sorry if I'm pronouncing your name incorrectly. Today's lesson is completely separate from yesterday's. Yesterday we looked at Power BI and visualizations. Today we're looking at machine learning and Python. Now, yesterday, like I mentioned, we looked at visualizations, and you have the equivalent thing. You have the equivalent option in Python as well to make graphs and visualizations using Matplotlib and Seaborn. So Matplotlib is kind of the de facto premier library for making any sort of graphs or visualization. And Seaborn is kind of built on top of it, and it is a bit easier to use. And by default, it makes a lot more prettier graphs. And Jolan, that's kind of what I'm explaining. I'm explaining the purpose of each particular library. Then we have sklearn, which is the most common and most popular library for machine learning. So it has do machine learning without having to write each and every aspect of mathematics yourself. And from it, we're importing basically data sets and linear model, which is where the machine learning model that we'll be training comes from. And when you're training machine learning models, similar to how a child kind of learns, you test them, you quiz them to see if they've learned something. And similarly, we'll be testing our model, and we test it using the mean square error and R2 score, which are kind of metrics or tests for regression-based models. And then there's also this test train split, because like how a child learns, you typically, the teacher might give them some examples to do during class, and then when the exam comes, they are given some questions which they haven't seen before, but which are of the same type. The case is similar here. We divided the data set into the training part and the testing part. And finally, actually, we didn't really hear the model that we've imported in question. So the linear regression model. And finally, we have our seed, which is 42. And again, because we're dealing with random numbers, this will kind of make sure if you set the same number for the seed, it'll make sure that our, yes, you can type the codes in, like follow my lead as I go along if you like, or you can just watch. It's up to you, but I recommend if you can get hands-on to get hands-on. And this kind of, again, when you're initially training something, this is also good practice. It enables you to basically, for your results to be reproducible. So, and thank you, Zine Sepula, for sharing what I've kind of written down so far. So this is the first aspect, which is again, loading the particular libraries. In the next aspect, I'm going to create another text cell and explain that what the next thing is to load the data set. And you can load the data from anywhere. You can load the data from any particular location. It can be a SQL database. It can be anything. Okay, you just have to, it's a bit more involved to configure the connection. In this case, I have a CSV file. So you can see the tab on the left-hand side, and you have the option to, again, you can see secrets, you can see variables, you can see find and replace, table of contents. So we will go here to files, and I'm going to upload a file. So this is the upload button. I will upload this to this, again, current session that is going on. And what I'm going to upload is the housing prices.csv file. And you might have noticed that now this file has been uploaded. If it doesn't show for you after you've clicked upload, just click refresh and it might show up then. And another thing that I'm going to do is I'm going to rename this, because again, having the housing brackets one kind of unnecessary. So I just renamed during to housing.csv. And now I'm just going to simply load this particular data set. So like I mentioned, pandas is the library that we use for working with, it's basically the equivalent of Microsoft Excel or Glue. So I'm going to load it using pandas. So the typical convention using pandas is df is equals to pd.read underscore csv. And since it's a CSV file and what I'm loading is housing.csv. So I did not run this cell. So you might have also noticed that there are these play buttons on the side. So if I click this, it kind of gives me an error, and it says that matplotlib.pyplot. It says, okay, there's no library by this name, meaning this is a very common error that we kind of face, meaning I made some sort of mistake in the import. Matplotlib. Yeah, I wrote pylot. That's the problem. It's pyplot. So I run this again, and you will notice that it runs. I haven't really loaded the dataset again. I uploaded it, and this is what will be used to load the dataset. So I haven't really pressed the play button here, which means to run this code snippet. You might have noticed since I ran this, it has a tick mark here, which shows that it has been run, and it took 3 seconds for it to run. So it also shows you how long it took to run. So another tab right here is basically your variables tab, and it's very useful in the beginning. like when you're starting things out, it shows you all of the variables that you've created. So far I've created one variable which is known as seed. Okay. And variables are stores of data. And in this case, the type is integer and it holds the value of 42. And if I click it, I can see the value stored inside of it. Similarly, right now there's no other variable. Now when I click this, a new variable will be created known as df, which contains our data set. So our data set has now been loaded and it's not showing up here. It refreshed and it showed up here. So this is again, the data set has been loaded. You can verify it here. And you can see this is the shape, meaning it has 20,640 rows and 10 columns. So it's quite a big data set. So this is how we load the data set. It's the same process for any CSV file. You'll just need to change the name here to, again, reflect the actual name of the file. So yesterday I told you guys that your job as a data scientist is to be a detective, to look at different aspects of your data and to try to find patterns or try to find things that are interesting. And that's kind of what we're going to do. So what that is known as in data science, it's not really called detective work. Okay, it should be. It's basically called as EDA or exploratory data. So it's a part of your detective work. It's called as exploratory data analysis. So what goes on in EDA, you basically look at different aspects of your data to find any problems, to find patterns or anything of the like. So the first thing I would like to do is I would like to take a look at my data to maybe get an idea about what it looks like. Or the representation, and I can just see a small, again, subset. So Excel is completely GUI. Like I can see a small portion of it using the head command. So I can do df, which is name of the variable, dot head, and run this. And by default, the head command will give me the first 5 rows. So I can see that latitude, longitude, this is what it looks like. These are floating point numbers, the median ages, the total number of rooms, and you might notice that the rooms are very large, like what house has 880 rooms. So this data set does not look at individual houses per se, it looks at housing blocks, which has multiple houses in it. So it's trying to predict the prices of those blocks. Then you have the total number of bedrooms, the population, the number of households, the median income, the median household value, and the ocean proximity. So these are kind of all of the variables that we'll be working with. But again, these are just 5 rows from a total of 20,640, if I believe I'm not incorrect. And if you're getting an error, it means that, again, you have not particularly run the cell. If you have run this cell, which is very important as PD, if you run this, then you will not really get this error. And Samantha, good job. You explained it well. Your import of pandas is probably not done correctly. So this is what the dataset looks like. We have an idea now. So we're going to be looking at, we're going to simplify things a lot. So there are a lot of variables here that are quite important. But again, to simplify things for this very short workshop, we'll only be working with 2 important columns out of the total, again, out of the total 10 of them. And the 2 we'll be working with are essentially the median income and the housing value. Because again, median income, we know for sure it's very important because the more your income, the more expensive the house you're going to be living in. And it's very likely that your neighbors are also going to be quite rich. So df is equals to df. So I'm just going to take 2 of the columns. The first one is median income. And I can just copy them from here. Control C. These are the tools. These are the only 2 I want. And the second one is median housing value. There we go. So now if I run this, I will only be left with these 2 columns, and to verify it, I'm going to add another quote cell and I'm going to do df.head. and it will give me, these are the two columns that I am working with. And again, by default, the head column or the head command just prints out the first 5 rows. Similar to head, you also have tail, which prints the last 5 by default. If I want to print, let's say, another number other than default, I can replace the value inside of head, inside of these brackets, inside of this function, the number. Let's say I want to print the first 10. So I put in 10, and now it will print the first 10, like so. So this is kind of what the data looks like. So we have maybe changed a few things in our data set. That's also part of EDA. Let's take a look at some of the basic statistics to get an idea. So instead of having to manually write a function to calculate the mean and other attributes, again, that's the beauty of libraries, because again, a lot of the work is done for you. So I can just do df.info, which gives me some information about basic stuff, such as what is the data type, it's sort64, the total number of variables here, and these are the non-null variables, meaning there's no missing data. You don't really need to install pandas as in Sabula. You just need to make the imports like this and run this. In Colab, everything is installed by default. You don't really need to install anything. That's kind of the use of it. So what do we do next? There are some other statistics that we can kind of look at. So we started the EDA process, and maybe I'll rename this to initial EDA. Clicking this, and I'm going to call this initial EDA, and I'm just going to remove this. There we go. I'm going to create another cell down here, and it's a text cell, and I'm going to call it EDA and data pre-processing. So here we'll be actually doing our detective work. Here we'll actually be going into the detective work, and don't worry, I'll go over the code once I finished it, if once more. So now we'll actually be looking at other stuffs in the data set. So we already know that we have 2 columns, but if we are not sure and if we want to verify again, we can just do df.columns. And if I run this, you can see I get an error because it says there's no attribute called columns, because I made a mistake in the spelling, which is a very common thing. So I have 2 columns, one is the median income and one is the median age. So perfect, everything seems to kind of be in order. Again, let's do the df.head again, df.head. And we see that these are the first 5 values. And I also told you about df.tail, which shows us the last 5 values. So again, this is the indexing. So you can see these are the first 5 and these are the last 5. And adding another quote cell, you have another option. You have df.sample, which randomly takes values from the entire frame. So SAMPLE. In this case, let's say I want to take 5, so sample of 5, and this will just randomly take the values, and it's much better. It gives you a much better idea of the values. So I've randomly sampled them. They're not in order, as you can see here. They've already seen ds.info. I'm going to show it to you again. df.info. And what this does is, again, what am I doing here right now? I'm basically getting an idea about the data set. So these are what the first 5 values look like, and these are what the last 5 values look like. And I can notice that, again, there doesn't seem to be anything weird happening to the data. Like, for example, here the values are, again, they're from 0 to 10, what it looks like. And here they're also from 0 to 10 for the median income. I don't really have a big value or something weird like 40,000. At least I don't see it. So everything seems to be following a pattern. Similarly, for the pricing of the median house value, you can see the prices, they do vary, but I don't really see anything weird happening. Like, for example, I don't really see a house price in negative, at least in the initial look. So this gives me an idea about the data set and what it looks like. And even when I randomly sample, it seems things are in order, but again, the sample size is small. So it's basically, um, I am able to tell that things look fine. But again, just because things look fine doesn't mean they are fine. This is just surface level inspection, so we typically do go in deeper. So the info function, what it tells me, for example, is the data type and if there are any missing values. And luckily, we can see that there are no missing values. And usually there are missing values in data that you'll be working in the real world. And that is an involved process to clean that data. So moving to kind of the next cell. So what we'll be doing next is another function, which is also very useful. So this kind of gives you a bird's eye view of if something is wrong in your data set. And that's using statistics. So df dot describe. I'm going to use this and I'm going to press enter, and you will notice that it has given me the count or how many values there are for the column. So again, we know there are 20,640. Yes, that is kind of correct, Milton. Though that's not really the focus. The focus is towards machine learning, and this will build up to its ETL stands for extract, transform, and load. It's related to data management and data. Again, it's more of a data engineering. We are doing that a bit, but again, the primary focus is machine learning or to train a machine learning model to make predictions. So as you can see here, we have the count. These are the values. You have the mean value, as you can see here. You have the standard deviation. So how much is the variation of the within the data? You have the minimum. Again, you have the basically the minimum value in the data set. So we can see that the minimum income overall in the data set is 0.49, and the minimum price of the house is $14,999. And the maximum, again, it seems like the maximum median income goes to 15, and the maximum value goes here. So again, we can see that this is kind of the range. We don't really see anything weird here. So typically, if there are problems in the data set, you might see something weird. For example, you might see a negative value. That also happens quite frequently. But you might see a zero value. Even if it's a zero, for example, if you have a zero for basically maybe the minimum price, no one has an income of zero. Okay. You are getting money from somewhere. So you do kind of have money or source of income, even if that's support from the family or something. So that is going to indicate a problem. Similarly, if you have if there's weird numbers here in the median housing value, you know that something is wrong. So now that we are done with this, we can actually check other stuff. So we already know that there's no missing data. We saw that from the non-null here, but we can also verify it manually. So how can we check if there's no missing data? So we can just do this df dot is NA. What this function does is the is NA function. It tells you if there are any missing values. So if I run this, it will tell me that there are no missing values, but again, this format is not readable. So I can do a dot sum after it. And I got an error. So I'm just going to do a dot sum. And what this will do is it will add them up. So again, there are no zero values in this column and no null values in this column. So our data is basically complete. We don't have any missing values. So as you can see, again, everything seems to kind of be in order. So next up, we will look at a very important aspect in when we are working with data and exploring it for machine learning. and that's to basically look at correlation. So do you guys have any idea what correlation is? Take a guess in the chat. So correlation basically relates to how closely some things relate to each other. So it's the relationship between two variables, yes. So if you're trying to predict something, again, one of these variables, so we are trying to predict the median housing value. Okay. So one thing is what we're trying to predict, and the other thing is what we have to predict it. So in order to make the prediction, these two have to be like related. There has to be some relation between them. For example, just to give you an example about correlation, um, my age and my year of birth are very highly correlated. So I'll upload the file once again in the chat. Like I've uploaded it 3 times by now. It's in the chat already. You might need to scroll along in the chat, like you have access to the CSV file again. And what we have here right now is again, uh, can you tell my age from my birth year? Please tell me that. If you know that my year of birth, can you tell me how old I am? Can you also tell how old I am from, let's say, which grade I am in, or how much I've studied? It's not going to be a completely accurate guess, but again, it's going to be a good guess, no? If I'm in the 8th grade, you can you can actually estimate my age quite well. Again, it's not, again, you can't tell 100%, and that's not the goal, but you can make a very good guess because there is a relationship. Similarly, if I'm doing a PhD, you can guess the range of my age. So there is a relationship. You know that I'm not going to be 5 years old if I'm doing a PhD, right? Similarly, can you tell my age by the color of the shirt I'm wearing? Of course not. There's no relationship. Those are two, let's say, variables, the color of my clothing and my age, but in that case, there's no correlation. So again, to make a prediction, to make a good prediction, machine learning models are not magic. They're not going to predict the exact value. Okay. They're going to predict maybe a range or a value close to it. Because again, like it's a prediction. It's not the truth or the ground truth. So what we are looking at is basically the correlation. And again, Pandas has a very easy um, has a very easy way to give us a correlation. I can just do df.correlation dot corr, and if I run this, you will notice I get this kind of matrix. And again, the diagonal of this matrix, meaning this value and this value, this diagonal is always going to be 1 because again, we are comparing the two, all of the variables with each other. So again, in the first one, we're comparing the first one, medium income with medium income. So again, the relationship is equal to 100%. They're exactly the same. And this one has median value with median house value. So again, this is also 1. So what you're interested in are the non-diagonal values. So we can see that there is a 68% relationship between the median income and the median housing value. And we know this from logic as well. We know this that, again, if rich people live in a particular neighborhood, the prices of those houses are also going to go up because they pay their taxes. It is actually the case because, again, they pay their taxes a lot more. If you pay taxes, if your neighborhood is peaceful, which is typically the case, the prices typically goes up. And also they maintain their neighborhood quite well. Uh, we're talking kind of the relationship in general, like, and if the neighborhood is poor, again, it will be a lot less maintained. The roads might be uh, still broken. Again, people individually will not spend money to make the changes. And don't worry, I'll show this again. I'll go over all of this again towards the end. So I'm going to open another code snippet. And this time, what I'm going to do is going to basically try to visualize the relationship between them, which is also quite important. So this time we are actually going to be making graph. So um,
we're going to be making a graph right here. So df dot plot dot scatter. So we're actually going to make a plot, and this is a scatter plot. So scatter plot, again, another rule of thumb when you are working as a data scientist is that whenever you want to see the relationship between two numbers, okay, and the values are can kind of be random. So you are going to be using a scatter plot. So I'm just going to, again, X in this case is median income and Y is median household value. So if I run this, you'll notice we get this plot. And this kind of shows a relationship between them. Like, I'm just going to take the pencil, and this is the relationship in question. And why can I not draw? Okay, it works. So actually, no, I closed it. So again, opening this up. So the relationship goes something like this. Again, I cannot really draw straight, but it's a linear relationship, which shows that when the median income goes up, the median household value also goes up. And there is a hard limit at this value. So again, this was the price of the most expensive house, if I remember. But there are also some other limits or ceilings. Maybe for neighborhoods or something, we can see that there are other boundaries in the data as well. So this is what being a data detective is kind of all about. You can see this clear pattern. Like you can see this pattern of dots. So this at the top is the stopping boundary. So we can see that this is the hard limit. And there are also some other boundaries, and the more we explore, the more we might understand them. But this kind of shows that we verified it, that there is a relationship between them. But again, we did not, I knew again, logically what the relationship was, I shared it with you. But this proves that there is a linear relationship. The more one thing increases, the more second thing increases as well. Now, the relationships can be positive, they can be negative, like it can go either way. And also how strong the relationship is, like we saw here, it's like 68%. That's how strong it is. So that's why this is also so steep. So if the relationship was weaker, maybe the line would be something like this. So we have to have a much more increase to increase the other. So removing this, we verified that yes, there is a linear relationship between them. But now we need to kind of make some other visualizations and look at some other stuff. So I'm just going to remove this toolbar. Okay. Open up another code cell, and this time I'm going to use a box plot. And now a box plot is another type of visualization, which maybe you might not have worked with before too much. It's used quite frequently and quite a lot in machine learning or in data science. And I want to basically look at the median income like so. Okay, I'll run it as it is. And once I run this snippet, again, I can visualize or make any sort of plot I'd like. Okay, in this case, basically the plot is in the X direction. I might change it a bit. So Y. So this is what the plot looks like. And you might notice something. So this right here, this line in the middle of the box is basically a median value. These are the percentiles. These whiskers of the plots are kind of, so this is basically the 25th percentile. This is the 75th percentile. And this again goes to statistics. So things that are above this line right here, or these whiskers, they're typically outliers. So they are weird values that don't necessarily fit the statistical pattern. So we do have outliers. So outliers can exist for any reason. For example, um, for those of you who attended yesterday's session, you might remember that for that airline, they did not really they were actually making a loss in 2019. And that was because of an outlier or outliers. Do you know the reason why they didn't really make much sales in 2019 and they were going in a loss? You remember? And even if you did not attend, like what happened in 2019? It was a global pandemic, it affected everything. So that was an outlier condition. So that's kind of outside of the normal. So this kind of helps us to see things that are outside the normal. So there can be many reasons why things are outside of the normal in terms of housing. Maybe, for example, The housing society is made by someone famous and they're charging a lot of money. Let's say, so in case you did not know, Donald Trump, for example, also has his construction company, and though he primarily delves in hotels, you can imagine he's going to price things a lot more expensive than, let's say, a regular person who owns a hotel. So the prices don't necessarily reflect uh, normal factors. It's more of according to his will. So we can see that there are outliers, and outliers kind of affect your machine learning model, and you need to kind of uh, treat them before you train the model. So now we're going to look at something else, which is the distribution and what it looks like. And we do that using the violin plot, which is another plot which you probably have not really used up till now. But it's a very powerful plot that gives you at a bird's eye view. Okay, violin plot, and we're looking at the median income. Perfect. So I'm just going to press enter, and I'm just looking at the data and seeing what kind of story it tells me. So you can see here that this is the distribution of the data. Now the violin plot, what it is that basically if you just look at half of it, it is basically if I plot out the distribution of values and then connected the dots. So I can see that um, the vast majority of houses, okay, are, so if I go here and again, let me open up the annotator. So, and let me switch things up. So the vast majority of houses are around this region, which is going to be in the median value of houses. Okay, this is probably where the median is, and this is also indicated by this white dot. So there are certain outliers. For example, as you go ahead, so you typically get rid of outliers because they don't really follow a pattern and you cannot really account for them. They're outliers, they're not normal. So you tend to remove them most commonly, but there are other ways as well. The simplest way is to remove them. So you notice, for example, the housing as the trend goes up and up and up, like there are not a lot of houses here, but again, the amount of houses increases. You can see that by the thickness, where the thickness increases, and then it goes on decreases, and then towards that, the pricing of the houses increases by quite a lot compared to what was before it. Now, why do you think at this particular house value, like when we get to the really expensive houses, why do they get so much more expensive? And why are they a lot more houses at this range? Actually, this refers to the income. So why are there people at this value who have a lot more income? So this kind of goes back to the natural statistics. Again, this is called as a normal curve or a bell curve. Uh, the vast majority of people, so there are not a lot of rich people and not a lot of poor people either, if you're talking about the numbers themselves. Okay. The vast majority of people are going to be middle class people, lower middle class, and upper middle class. Which is kind of shown here. And there are going to be poor people, but as you go up or like above or below, the amount of people kind of decreases. When you go to the rich people, again, at the very rich, there are going to be some people who have a lot of income. Like, for example, in America, um, I believe the billionaires such as Elon Musk, Jeff Bezos, there are others who I do not really remember, but they kind of encompass or they kind of control like the vast majority of wealth. And this is kind of shown here as well that these kind of elites at the top, they have a lot of money. And this is again, the thickness kind of refers to the number of people, okay, with this level of income. So you do have a very few people, but with a high amount of income. Anyway, this is what we see in this plot. Okay, nothing really like everything that kind of follows common sense and logic, nothing that's illogical. Now, I'm going to show you another very powerful plot, which also helps us to see the relationships very strongly as well as the distribution of both of them. So this is when you're comparing two variables together with each other. So I'm going to open another code cell. And this time what I am looking at is basically underscore. I'm going to go down
is equals to SNS dot join plot, and X is equal to medium income. So everything seems to be correct. So again, this AI assistant is very useful. I'm pressing tab, and when I press enter, it gives me an error because it does not really have an attribute called join plot. I think it did at one point, but it got removed. So this is where I show you another very powerful feature of Colab, I think. So you can use Gemini, and if I get an error, I can just ask it what that error is, and this will help you guys quite a lot. So I get an error here. I know what the solution is, but so I'm just gonna ask it. I am getting the error. So the error we're getting is because, again, this was in an older version of Seaborn that they use this name. They changed it, so now it has a different name instead of join plot. So if I run this, so it's telling me again, it's okay, join plot, reset runtime. These are in, yeah, okay. So actually, there are things that were updated. So the reason I got this error is because it's not join, it's joint. So if I run this, it should work without problem. But again, you got to see this very useful tool that helps you debug. So I was able to verify. So this is what the joint plot kind of looks like. You can see on the left hand side, again, it's similar to the scatter plot, a lot more detail. On the left hand side, you have the median house value, and on the right on and below, you have basically the median income, and you have the distribution of each of them here. So you can see the median house value. So for a lot of houses, so they seem to be the opposite of each other, the distributions. Actually, no, actually they're the same, sorry, my bad. So you can see that when you're starting out from the beginning, from again, 0, there are a lot more houses that there are a lot more, again, most of the income is again, middle class or lower middle class. So in the middle range, a lot less income is very high up or very below, but there are a few people who are ultra rich or extremely rich. So, for example, you can visually see that there is no connection between this person and this like block. So this person or the group of people here are kind of, these group of people are kind of outliers in terms of the income. And this region here is also called kind of an outlier. And similarly, if you look at this distribution right here, the median household income, we can see as we start, again, in the middle, we have the highest kind of values or the average, okay? But as we kind of go up, there are not a lot of people who are extremely rich too much. Sorry, there are not a lot of houses that are too high in value, except when we reach this point, which is this hard line right here. And you can see that this is a lot bigger, and this does not really match the trend. Yes, it is a normal distribution. Most things follow a normal distribution. It's not a perfect normal distribution, but so this is also an outlier because it does not really follow a trend, and like there's no pattern that I can kind of see. So, okay, so I'm getting a lot of insights in my data. So I know what to do, I know what to clean and stuff like that. And one other thing I can do, so I'm just going to copy this and just to show you, I can also do regression or plot a regression line, which kind of visualizes what I did by hand. Okay. You don't have to do it by hand. So I can do kind equals to regression, REG. And when I run this, you will notice that now it looks slightly different with a new kind of feature. So you can see that again, they've drawn a curve. So when you type is equal to regression, you can see the curves, the smoothed out curve. In both cases, this is for sure an outlier. And you can also see the regression line. So this is the relationship between them. This is what that line looks like, the relationship between them, which I do manually. Again, you can do everything in Python. So what I'm going to do is I'm going to remove the outliers. So I'm opening a new code cell and I'm going to write Actually, I'm going to open a new text cell, okay, and write. Why do I write this in text? Because again, that makes things a lot easier for you to understand when you, again, go back to your code. So I'm just going to do df.drop. And I'm going to do this and place equal to df median income. So actually, no, I want to basically for the median housing values. So I want to remove this outlier right here. So I want to do MEDIN. So it's median underscore house underscore value. And I want to remove everything that's kind of greater than 5. Well, technically nothing is greater than this value. So the maximum amount, if I remember, was 500,000. So maybe I can set the limits to something lower. So let's say I set it to 45, 1, 2, 3, 4, and 4 zeros, 1, 2, 3, 4. So this should hopefully get rid of most of the outliers that are kind of causing this bump. So if I run this, so it seems like, okay, well, you see the caveats. Yes, I'll drop. Yeah, so assuming that everything is on order, we can make the visualizations again. So I'm going to make the violin plot again, or take a look at the violin plot again. So I'm just going to underscore equals to SNS, okay, SNS dot violin. And here we have the autocomplete of the median housing value. If I run this, it should look different, and it does. You can see that those bumps are not really there. It looks like a more normaler distribution. Okay, this was the violin plot before. So we have successfully managed to get rid of the outliers. Similarly, if I move on, code. If I look at the joint plot that I made above, so I can just do equals to SNS dot joint plot. And I'm just going to run this again. You'll notice that that bump is no longer there. That outlier, since I cropped it to 50, 45, that's why, again, it's at 45. But you can see the outliers are kind of gone. You can visually not really see the outliers anymore. So which is good. So it's a general rule of thumb that you always get rid of the outliers. So again, the more when you practice this on your own, guys, or when you actually do take, if you do decide to sign up, you go over each one of these steps on how the visualization works and why you look into it. We go much more into the intuition, but again, in a 2-hour course, it's very difficult to go over each and everything. So all of them, they represent different things. Again, this is not really for the client. This is for your own understanding. So what we're doing right now, like I mentioned before, if I go up, where did I write it? We're doing EDA and data processing. So this is for you to clean the data and for you to understand the data, because there are a lot of machine learning algorithms you can use, and it depends on the kind of data you have. So you are understanding the data. These visualizations are for your own understanding on how you're going to work with it. But again, when you're presenting things to the client is probably just going to be interested in the housing prices. So maybe a map with the locations where they can see the prices of the houses. That might be just the only thing they're interested in, and that's actually what we're working on. So now we have actually done the visualization. Now what we're going to do is actually work on the training. So the third step is preparing the data for training. It will actually affect your accuracy. The outliers are important because they kind of affect your results. Just to kind of give you an example, there are certain, so when you go to a doctor's visit, And if you take certain kinds of medication, maybe let's say you take antidepressants, just to give an example of the doctors will kind of ask you that because a lot of other medication and treatment, it kind of will affect or be affected by the other medicines that you take. You are an outlier. The treatment or the medicine is not the regular one, might not really work on you because of the, let's say, antidepressants that you take, or maybe even vitamins that you take. So things are designed to work in a specific way. If you have outliers, then things will not really work properly. Like, just to give you another plain example, your car is supposed to work with 4 wheels. If one of the wheels is busted, your car will not work. Sure, you can try to, if the one of the wheels is like punctured, you can try to force your car to go along. What will happen? The car will not perform as well, and eventually your car engine will overheat. You will damage your axle. You will mess up a lot of things in your car. So the recommending thing is to actually wait if your tire is punctured and fix it before moving on. So what we will be doing now is, again, we are preparing the data for the machine learning process. So I'm going to separate the input from what we're trying to predict. So X, it's doing a good job here. So X is basically the median income input, the median income, and I'm just going to do things my way dot ilock. Okay, and we'll see what ilock is. Again, this is more of a pandas thing. So and dot values dot this, and for y it is basically equals to just the dot values. I have successfully split up x and y, which is something that I need. Next code cell. Now what I'm going to do is I'm going to split them into testing and training parts, and I've kind of already imported the test train split. So I'm going to do x underscore train, x underscore test, y underscore train, y underscore test, and this is basically how I split the data set. I'm not really going to shuffle them, so I'm going to set the shuffle equals to false, just in terms of repeatability. So random value is equals to seed, since I already set the seed before. Okay, and shuffle size equal to false, SHUFFLE. And again, it's not really that important right now to get into the nitty-gritty details, but essentially I'm making the test for this model. Just like a teacher, has to decide which questions he will be giving, and for examples for the student to prepare, and which ones are he's going to give for the test. There we go. Running this, and if everything is in order and things are not in order, and they're not in order because I forgot a comma. And now, as you can see here, it ran perfectly. So we have successfully prepared the data set. Okay. We could visualize it, but for the interest of time, I'm just going to move on ahead. And now we can actually train our model. So I've already imported linear regression up above. So GRESSOR. So again, as you're aware, machine learning and AI has a lot to do with mathematics. And but for you guys, again, you're using a library. You don't really need to write the algorithms yourself. So strict knowledge of mathematics in today's day and age, as compared to, let's say, 5 to 10 years ago, is not really required. So linear regression. So I'm creating, actually, no, this is a core, sorry, this is a text cell. So training, there we go. And here I'm going to do regressor is equals to linear regression. And here I'm going to, so this is me creating the model. And I can also add comments like this, interestingly, and this is me training the model or giving the order to start training. So the first thing is we're defining which basically algorithm we want to use, and in the second one we are kind of training it. I run this, you'll see it's running, and it did not take long to train. Like it almost happened immediately. And that's because simple linear regression is a very simple and quick algorithm. It's not really the best, but again, the goal, we're not really going for the best. Okay. So I'm going to show you and visualize the results, or the goal of regression is to basically make a line, okay, or in the case of simple linear regression, a line that kind of basically fits this model. Essentially, this is also the linear regression. So this is kind of the regression line between them. This line right here, this is kind of what we're trying to predict manually. So what I'm going to do now is I'm going to visualize the line manually and show you the results manually. So line is equals to, and I'm going to use what the model has learned, regressor.coefficient. Yeah, perfect. So this will basically, this is the definition of the line. And if you remember, this is y is equal to mx plus c, the equation of a line, the regression model that predicts a line, okay? This is the m, or the gradient. This is the input x, and this is the y-intercept. And then I'm making a scatter plot and showing it on top of the scatter plot. So if I run this is basically what the prediction that the model has made. So this is the model, what the model has found. So if I look for the prices, the model will again predict prices around this region. And again, simple linear regression is just one AI model or machine learning model that exists. It's the most basic one. So there are a lot more better models that you can use to actually make better predictions. And again, this model will not be perfect. As you can see here, for example, in this case, if I want to predict a house, this one, let's say I want to predict the value of this house. Well, the line will kind of drop it here. So it's predicting the median house value to be somewhere like 40, 50,000. So it's completely incorrect. So it's not really the best model, like I mentioned before, and it will make mistakes because it's making a prediction. So how many mistakes does it make though? How can we test it? So that's the next thing that we kind of test the model. So a new cell. So I select testing the model. There we go. And the predictions of the models are going to be called y-predict. And here is where we're making the predictions. And I'm going to make a comparison between them visually. This is not really the best way to compare. This is not really how we compare them. We use the metrics. Okay. So if I run this, again, autocomplete is making my life so much easier. Yeah, it does make life easier, but it also makes a lot of mistakes. So y-test, yeah, so it typed in y-test for both of them. So no, the second one is not y-test. It is, how do I know? How do I know it made a mistake here? I did not check in the beginning, but I can see the values match up exactly. Then they're never going to match up exactly. If they're matching up exactly, then you know for sure you've done something wrong. So it's actually why, okay, I made a mistake here. So I call this y-test. No. Again, sometimes the predictions are going to make mistakes, so I have to run this again now. I predicted. So I'm going to have to go up. I'm going to have to run this again, make the split again. I don't have to train the model again since I have the test value now. So I can just run this and there we go. And you can see that it's making a lot of, like, this is making blunders in some cases. So in this case, the house value is 91100. So not that expensive, but it adds another zero to the end. So the house is now much more expensive than it actually is. So this also kind of shows or highlights the importance of making sure that your model does a good job before you actually deploy it to the wild. So in some cases, it's not that far off. But in some cases, other cases, it's going to be. So moving on. we visually see that how much differences there are. We saw it here as well. Okay, then in some cases, yeah, the predictions are way off. Even in this case, if you want to predict the house here, it's going to predict the house value a lot lower than it actually is, because this is not really, again, a very sophisticated model. But again, this does not give us, like, this does not really tell us how good or bad the model is. Is there a way we can just maybe in a single word or in a single number, maybe know how good the model is? And yes, that is using the metrics that we defined. So evaluating the model. So we basically print, yeah, okay, seems to be okay. Print. Okay, print mean squared error. That is also okay. It seems okay. Y test, Y predicted. And the coefficient of determination. So just doing this, okay, this is a second metric, the mean square error, and no, and that's this thing don't want this per se. Okay, there we go. The coefficient of determination, which is the R2 score. So let me kind of show you. Basically, these two things here are just two numbers that just tell you overall without having to look at the graph and try to interpret it. You can just, as a fact, it tells you how good or bad the model is. So how do you read it? So this number is huge, okay? This is the error. So you want this number to be as small as possible. It's very big, which means, okay, there is a lot wrong in that. And also this number right here tells you the error rate. It's kind of the error, how many mistakes you made. You can also think of it in terms of accuracy, but it's not really the accuracy. But this model, you can think of it like this model is only 43% trustworthy, or it's only correct 43% of the time. You can think of it like this. And we actually did make the prediction right here. This is where we made the prediction, dot predict. So we did make the predictions, like we made the prediction, then we are verifying if, again, it's doing things correctly or not. So let's say now I wanted to make my own prediction, meaning I wanted to check the value of a particular house. Okay. The model is trained. Again, this is not really the best model, like I mentioned before. So you will probably want to choose a much better model and make sure its accuracy is a lot better. So my own prediction. There we go. So is equals to, so maybe I'm saying that the income is 4. So the income value ranges a lot. So I maybe want my income is, let's say 4. I want to do that, and maybe I want to know, this is my income, how much should I spend on a house? So this model can tell me that based on my income, how much I can afford to spend on a house, and it tells me that I can afford to spend this much on a house. And like I mentioned before, this is not the most accurate model, because we can visually see that this line or whatever the model predicts, the thing in red, it's supposed to best fit the data. This is a straight line. It does not best fit the data. We can visually see it. Like a better fit would be, for example, um, something other, maybe another model, maybe something like this, a model that goes zigzag or something like this that covers everything. Visually, that's what it's supposed to look like. But anyway, this was basically you training a machine learning model from scratch on your own data set to make a predictions. Is it a very good model? No, but you know how to train a model. And yeah, parabolic actually curve would be a lot better fit. So those are called non-linear models, and the algorithm we use is called linear regression. So that means there are also other regression models that are non-linear, such as polynomial regression, which are a lot better. But again, there are other more complicated models as well, which are way, way better at making predictions, such as XGBoost and the like. And the more you get into it, the more you'll get into this, um, the more clear these things will get for you. Okay, Fisher. Okay. So again, going over things once more very quickly. The first thing that we did was import the libraries as shown here, followed by loading up the dataset. And the dataset we loaded up by just clicking the upload button here. It comes here. And you notice the name that I put here is the same name as the data set here. Then I looked at the first 5 rows to get an idea about the data set. I decided to just take 2 values, and again, that's for simplicity, because in a 2-hour lecture, we have to cover everything and make sure that everyone, again, regardless of your level, can follow along. I have to keep things a bit simpler. Don't worry about it. Again, it's not really expected that you'll get everything. Like this comes with a lot of practice and a lot of understanding. Even if you're able to get a very small thing, consider this workshop that you attended worth it. Actually, even for me, like I've been doing this for 10 years. Even if I showed this, like if I wouldn't expect myself, if I was seeing this for the first time, to understand everything on the first go. So we're working with these 2 columns right here, and followed by that, we look at basic statistics. We see that they're no null values. You see that these are the 2 columns. So this is where the EDA comes in. And I look at basically the first 5, the last 5, and random values. And this is more of to show you how you can just look at the values. And then I see the info again, no null values. I see the basic statistics, and the statistics also tell me that, again, there's nothing really weird. And I will share the Python file towards the end. Don't worry, guys. Then I check if there are any missing values manually, and they are not, which is again the same as what I saw here. So no null values, everything is clear. Then I see the correlation, because again, before I can make any prediction, I need to make sure that the thing that I'm trying to predict is related to my data. And that's where I look at the correlation, and we can see that there is a relationship manually. Then I look at basically there are outliers using the box plot, and indeed there are a ton of outliers. There are outliers in both cases, not just in income, but also in the housing prices. The violin plot also shows me the same, and using the joint plot, I'm able to compare them side by side. And I can see here that indeed there's a huge outlier here, which I need to get rid of. Then I show you a different kind of plot, the regression plot, which again plots a regression line, a linear regression line. And again, these 2 are the same thing, but this shows you the pattern and verifies the pattern. Now that we have an understanding, again, the reason why we did this was to understand our data and to correct for any mistakes in it. In this case, the only mistake was the outliers. So that's what I do. I remove the outliers here. I don't keep any value after 45,000. And that's all just random. Again, there are other ways to do it as well. And after removing the outliers, you can see how much smoother things are now. So smooth here as well, outlier gone. If there are outliers in your data, your model will perform even worse. So removing outliers is extremely important. They're called outliers because they do not fit any pattern. They don't have any pattern. And what machine learning models or even humans learn to do, they learn to find patterns. Other than if you don't find patterns, then that's just memorizing, and then you can not really predict anything with memorization. You're learning. So here we are actually preparing the data for training. We're splitting again what we're trying to predict versus input. Okay. Then we split the data set into the training and testing parts, just like a teacher would do. They would have certain questions as examples for covering in the class, and certain other example, like questions for the quiz or the exam. And thank you guys. I really appreciate the compliments. And even if you guys are not able to follow everything completely, trust me, it's not your fault. Like this takes a lot more classes and a lot more, again, a lot more in-depth practice to get the hang of. And even if you understood just one small thing, again, that's progress here today. So here's where I created the model, and I trained the model here. You see this model has been created. It's just a visualization. And then I basically show the predictions that the model has made in red. So this is the predictions it made, and I can visually see that this is a very shit model. Its performance is not as good as I would want or expect, sadly. But not to worry, there are a lot more models you can use. And again, we are just using one input data point. There are more data points that you can use as well. So we can improve the performance in multiple different ways. Then I again visualize them side by side, and you can see, yeah, it makes a lot of mistakes. But then I asked you the question, is there any way to see them like, and again, I'm going to show this notebook towards the end so you can practice on your own. But is there any one value that can tell me how good or bad it is? Yes, in this case, there's the mean squared error. So you want this value to be as small as possible. The bigger the value, the more shit the model is. And you want this number right here to be big as possible. This means like your model is even less than 50% accurate. And then finally, I show you how to make a prediction with your own value. Again, in this case, my salary range is, let's say 4, and I want to predict what house I can buy or what is affordable for me. And this is what I get. So yeah, that is it basically with the hands-on tutorial of using Panda, using basically Python to predict the housing prices. So I'm just quickly going to stop the share and sorry, I'm quickly going to go back to the slides. So the slides are here. There we go. So the expected outcome that was basically the basically development of a predictive model that could enable Sunshine Realities to provide clients with an accurate estimate of median housing value and enhance their ability to make these informed decisions. And indeed, we did train a model that kind of does just that. And I really hope that you guys had a great time learning this skill. Like, please let me know in the chat and please use your emojis if you liked today's tutorial. And if you just learned just one small thing, like that's progress. Let me know in the chat and with the emojis.